Thank you. Hi, my name is Eunsuk from CMU, and I'm one of the co-PIs of this project. We know that there's a lot of interesting and sensitive data within scientific computing infrastructures that we would like to share with our collaborators. And the goal of this project is to help researchers securely be able to do this, right? To share their data and author access control policies that will ensure that only those who should be able to access data are actually allowed to, able to access data. And this is not a new problem, right? We know that creating secure access control policies can be challenging, especially for those who are not experts in security, like researchers. And one of the problems that we think is that we're trying to address in this project is that there is a fundamental gap between how researchers think of access control versus how these policies are actually realized in the underlying infrastructure system. For example, if you're a researcher working on a project, you may be thinking of access control in terms of maybe your collaborators or maybe your grad students who should be able to access certain kinds of data and maybe not be able to write to other kinds of data, right? So those are sort of very high level concepts that appear in their scientific workflows. But eventually, those policies may need to be realized as file permissions or other kind of low-level primitives that exist in the underlying infrastructure. So the goal of this project, or one of the key ideas that we're trying to address here is that can we allow or can we build a tool that will bridge this gap between these two levels of abstraction such that the researchers are able to understand and author access control policies at the level of abstractions that are comfortable for them, that they can actually comprehend, instead of having to understand how these are actually realized as much more low-level objects. So this project will combine techniques from formal method as well as AI. So we're using AI to take the natural language description of what the researchers want in terms of their security requirements into access control policy objects. And then we're using formal method to extract these low-level policy objects from the underlying infrastructure and compare them against the high-level access control concepts that's been extracted or that's been translated from the natural language description. So there's, a little bit of sort of a constraint-based analysis that we're planning here using SMT, as well as using AI or maybe large language models to translate the natural language requirements into a more formal access control policy objects. So some of the benefits of this project, if it's successful, we think that this could help improve the security of scientific computing infrastructures by allowing researchers, or having them give them easier time actually authoring and understanding the effect of the access control policies that they create. But also, we think that there will be new advances in terms of new concepts in access control policy security, as well as perhaps new method in AI, using AI to translate security requirements into more formal objects in terms of access control policies. So one thing we're doing, the way we're going to sort of implement or carry out this project is using on top of a framework called TAPIS, which is a well-established infrastructure framework that's been hosted at UT Austin, and that's being used to support a wide range of scientific computing projects around the country. Now, at the same time, we think that the things that we learn from this project should be generalizable and reusable across different types of scientific computing infrastructures out there. Now, in terms of data sharing, we would like to share as much data as we can. So we're going to make all the tools open source and everything, but some of the data we're dealing with here are kind of sensitive because these are access control policies. So, perhaps you're thinking about maybe sanitizing some of this data that can be used by other researchers working on access control policies. So we have some ideas about that, but we haven't sort of fully worked that out yet. But, I'll be open to hearing about whether, anybody's interested in this kind of problem or, if there's some way to share this type of sensitive security data, I'll be interested here and we'll discuss more of that. But yeah, so this is the overview of the project, and I'll be happy to take any questions.
Great, thank you so much. So this is great stuff. This is we intentionally wanted to kind of end on this one, right? So I'm here, similar to many of the other projects, these are not very intensive in terms of needing to put large data sets up into OSDF or NDP, right? And so they don't for anybody here, but and especially with this, there's not an expectation that you put you put some data sets up there. Where this is going to, I think, become is getting even more interest and excitement. Uh, if all of you haven't had the fun of having this yet, you probably will, if you haven't already this semester, get an additional training class that is from all federal agencies about research security and how you have to, how we have to worry about open data being compromised and enforcing, appropriate access control policies. Not we're hugely in favor of collaborative data. As you can see, we're trying to push everybody to get data up there. But there's also guidance coming out to say like, hey, I I want my data released at the appropriate time to the appropriate groups. And this bridges a huge gap between folks like many of us who can talk about like, well, wait a minute, are we really talking about RBAC or ABAC or what kind of what kind of access control rules are we doing? And I think if many of the users out there, if you said like, wow, is this are you thinking about an RBAC or ABAC approach to access control? They're going to be what are those words, right? And so this really could be very compelling and huge. And so it's less about pushing the data out into the system, but more about what access controls do we put on there, and how do we get the people who really know how their data should be shared, talking to those cybersecurity experts, and I think many of us would put ourselves in that category, that understand how to implement it. So this is very cool stuff. Looking forward to seeing all 5 of these projects. If we can get all this, I tell you guys, at the end of these 3 years, we're going to have much better, much more secure overall scientific computing, whether it's our HPC centers or our better secure GPUs or better incorporating our trusted execution environments, understanding the provenance, integrity, authenticity of our data, and letting scientists write reasonable policies to do it. This would be we're pretty excited about all this. I know I'm running a little bit over time by just a minute or two here, but I appreciate all you guys' time.